An operating system is system software that manages computer hardware and software resources and provides common services for computer programs. The operating system is a component of the system software in a computer system. Application programs usually require an operating system to function. Time-sharing operating systems schedule tasks for efficient use of the system and may also include accounting software for cost allocation of processor time, mass storage, printing, and other resources. For hardware functions such as input and output and memory allocation, the operating system acts as an intermediary between programs and the computer hardware. Although the application code is usually executed directly by the hardware and frequently makes system calls to an OS function or is interrupted by it, operating systems are found on many devices that contain a computer, from cellular phones and video game consoles to web servers and supercomputers. Examples of modern operating systems include Apple OS X, Linux and its variants, and Microsoft Windows. Types of operating systems. Single and multitasking. A single tasking system can only run one program at a time, while a multitasking operating system allows more than one program to be running in concurrency. This is achieved by time sharing, dividing the available processor time between multiple processes which are each interrupted repeatedly in time slices by a task scheduling subsystem of the operating system. Multitasking may be characterized in preemptive and cooperative types. In preemptive multitasking, the operating system slices the CPU time and dedicates a slot to each of the programs. Unix-like operating systems, e.g., Solaris, Linux, as well as Amigos support preemptive multitasking. Cooperative multitasking is achieved by relying on each process to provide time to the other processes in a defined manner. 16-bit versions of Microsoft Windows use cooperative multitasking. 32-bit versions of both Windows NT and Win9X used preemptive multitasking. Single and multi-user. Single-user operating systems have no facilities to distinguish users, but may allow multiple programs to run in tandem. A multi-user operating system extends the basic concept of multitasking with facilities that identify processes and resources, such as disk space, belonging to multiple users, and the system permits multiple users to interact with the system at the same time. Time-sharing operating systems schedule tasks for efficient use of the system and may also include accounting software for cost allocation of processor time, mass storage, printing, and other resources to multiple users. Distributed. A distributed operating system manages a group of distinct computers and makes them appear to be a single computer. The development of networked computers that could be linked and communicate with each other gave rise to distributed computing. Distributed computations are carried out on more than one machine. When computers in a group work in cooperation, they form a distributed system, templated in an OS, distributed and cloud computing context. Templating refers to creating a single virtual machine image as a guest operating system, then saving it as a tool for multiple running virtual machines. The technique is used both in virtualization and cloud computing management, and is common in large server warehouses. Embedded operating systems are designed to be used in embedded computer systems. They are designed to operate on small machines like PDAs with less autonomy. They are able to operate with a limited number of resources. They are very compact and extremely efficient by design. Windows CE and Minix 3 are some examples of embedded operating systems. Real-time. A real-time operating system is an operating system that guarantees to process events or data within a certain short amount of time. A real-time operating system may be single or multitasking, but when multitasking, it uses specialized scheduling algorithms so that a deterministic nature of behavior is achieved. An event-driven system switches between tasks based on their priorities or external events, while time-sharing operating systems switch tasks based on clock interrupts. Library. A library operating system is one in which the services that a typical operating system provides, such as networking, are provided in the form of libraries. These libraries are composed with the application and configuration code to construct unikernels, which are specialized, single-address space machine images that can be deployed to cloud or embedded environments. History. Early computers were built to perform a series of single tasks, like a calculator. Basic operating system features were developed in the 1950s, such as resident monitor functions that could automatically run different programs in succession to speed up processing. Operating systems did not exist in their modern and more complex forms until the early 1960s. Hardware features were added that enabled use of runtime libraries, interrupts, and parallel processing. When personal computers became popular in the 1980s, operating systems were made for them similar in concept to those used on larger computers. In the 1940s, the earliest electronic digital systems had no operating systems. Electronic systems of this time were programmed on rows of mechanical switches or by jumper wires on plug boards. These were special-purpose systems that, for example, generated ballistics tables for the military or controlled the printing of payroll checks from data on punched paper cards. After programmable general-purpose computers were invented, machine languages were introduced that sped up the programming process. In the early 1950s, a computer could execute only one program at a time. Each user had sole use of the computer for a limited period of time and would arrive at a scheduled time with program and data on punched paper cards, or punched tape. The program would be loaded into the machine, and the machine would be set to work until the program completed or crashed. Programs could generally be debugged via a front panel using toggle switches and panel lights. It is said that Alan Turing was a master of this on the early Manchester Mark Chapter 1 machine, and he was already deriving the primitive conception of an operating system from the principles of the universal Turing machine. Later machines came with libraries of programs, which would be linked to a user's program to assist in operations such as input and output and generating computer code from human-readable symbolic code. This was the genesis of the modern-day operating system. However, machines still ran a single job at a time. At Cambridge University in England, the job queue was at one time a washing line from which tapes were hung with different colored clothes pegs to indicate job priority. An improvement was the Atlas Supervisor, introduced with the Manchester Atlas, commissioned in 1962. Considered by many to be the first recognizable modern operating system, Brinch Hansen described it as the most significant breakthrough in the history of operating systems. Mainframes. Through the 1950s, many major features were pioneered in the field of operating systems, including batch processing, input, output interrupt, buffering, multitasking, spooling, runtime libraries, link loading, and programs for sorting records in files. These features were included or not included in application software at the option of application programmers, rather than in a separate operating system used by all applications. In 1959, the Share operating system was released as an integrated utility for the IBM 704, and later in the 709 and 7090 mainframes. Although it was quickly supplanted by IBSYS, IBJOB on the 709, 7090 and 7094. During the 1960s, IBM's OS 360 introduced the concept of a single OS spanning an entire product line, which was crucial for the success of the system. 360 machines. IBM's current mainframe operating systems are distant descendants of this original system, and applications written for OS 360 can still be run on modern machines. OS 360 also pioneered the concept that the operating system keeps track of all of the system resources that are used, including program and data space allocation in main memory and file space in secondary storage, and file locking during update. When the process is terminated for any reason, all of these resources are reclaimed by the operating system. The alternative CP67 system for the S360-67 started a whole line of IBM operating systems focused on the concept of virtual machines. Other operating systems used on IBM S360 series mainframes included systems developed by IBM, COS 360, DOS 360, TSS 360, TOS 360, BOS 360, and ACP, as well as a few non-IBM systems. MTS, Music, and ORVYL. Control Data Corporation developed the Scope operating system in the 1960s for batch processing. In cooperation with the University of Minnesota, the Kronos and later the NOS operating systems were developed during the 1970s, which supported simultaneous batch and time-sharing use. Like many commercial time-sharing systems, its interface was an extension of the Dartmouth Basic operating systems, one of the pioneering efforts in time-sharing and programming languages. In the late 1970s, Control Data and the University of Illinois developed the Plato operating system, which used plasma panel displays and long-distance time-sharing networks. Plato was remarkably innovative for its time, featuring real-time chat and multi-user graphical games. In 1961, Burroughs Corporation introduced the B5000 with the Mcp operating system. The B5000 was a stat machine designed to exclusively support high-level languages with no machine language or assembler. And indeed, the MCP was the first OS to be written exclusively in a high-level language, ESPOL, a dialect of ALGOL. MCP also introduced many other groundbreaking innovations, such as being the first commercial implementation of virtual memory. During development of the AS400, IBM made an approach to Burroughs to license MCP to run on the AS400 hardware. This proposal was declined by Burroughs management to protect its existing hardware production. MCP is still in use today in the Unisys ClearPath MCP line of computers. UNIVAC, the first commercial computer manufacturer, produced a series of exec operating systems. Like all early mainframe systems, this batch-oriented system managed magnetic drums, disks, card readers and line printers. In the 1970s, UNIVAC produced the real-time basic system to support large-scale time-sharing, also patterned after the Dartmouth BC system. General Electric and MIT developed General Electric Comprehensive Operating Supervisor, which introduced the concept of ringed security privilege levels. After acquisition by Honeywell, it was renamed General Comprehensive Operating System. Digital Equipment Corporation developed many operating systems for its various computer lines, including TOPS 10 and TOPS 20 time-sharing systems for the 36-bit PDP-10 class systems. Before the widespread use of Unix, TOPS 10 was a particularly popular system in universities, and in the early ARPANET community. From the late 1960s through the late 1970s, several hardware capabilities evolved that allowed similar or ported software to run on more than one system. Early systems had utilized microprogramming to implement features on their systems in order to permit different underlying computer architectures to appear to be the same as others in a series. In fact, most 360s after the 360/40ths were microprogrammed implementations. The enormous investment in software for these systems made since the 1960s caused most of the original computer manufacturers to continue to develop compatible operating systems along with the hardware. Notable supported mainframe operating systems include Burroughs MCP, B5000, 1961, to Unisys ClearPath, MCP, present, IBM OS, 360 IBM System, 360, 1966 to IBM Z, OS, present, IBM CP67 IBM System, 360, 1967 to IBM Z, VM, UNIVAC Exec8 UNIVAC 1108, 1967, to OS 2200 Unisys ClearPath Dorado, present. Microcomputers. The first microcomputers did not have the capacity or need for the elaborate operating systems that had been developed for mainframes and minis. Minimalistic operating systems were developed, often loaded from ROM and known as monitors. One notable early disk operating system was CP/M, which was supported on many early microcomputers and was closely imitated by Microsoft's MS-DOS, which became widely popular as the operating system chosen for the IBM PC. In the 1980s, Apple Computer Inc. abandoned its popular Apple II series of microcomputers to introduce the Apple Macintosh computer with an innovative graphical user interface to the Mac OS. The introduction of the Intel 80386 CPU chip with 32-bit architecture and paging capabilities provided personal computers with the ability to run multitasking operating systems like those of earlier mini-computers and mainframes. Microsoft responded to this progress by hiring Dave Cutler, who had developed the VMS operating system for Digital Equipment Corporation. He would lead the development of the Windows NT operating system, which continues to serve as the basis for Microsoft's operating systems line. Steve Jobs, a co-founder of Apple Inc., started Next Computer Inc., which developed the Next Step operating system. Next Step would later be acquired by Apple Inc., and are used, along with code from FreeBSD as the core of Mac OS X. The new project was started by activist and programmer Richard Stallman with the goal of creating a complete free software replacement to the proprietary Unix operating system. While the project was highly successful in duplicating the functionality of various parts of Unix, development of the new herd kernel proved to be unproductive. In 1991, Finnish computer science student Linus Torvalds, with cooperation from volunteers collaborating over the Internet, released the first version of the Linux kernel. It was soon merged with the new user space components and system software to form a complete operating system. Since then, the combination of the two major components has usually been referred to as simply Linux by the software industry, a naming convention that Stallman and the Free Software Foundation remain opposed to, preferring the name GNU Linux. The Berkeley software distribution, known as BSD, is the Unix derivative distributed by the University of California, Berkeley. Starting in the 1970s, freely distributed and ported to many mini-computers, it eventually also gained a following for use on PCs, mainly as FreeBSD, NetBSD and OpenBSD.